Here we are in the expressions section. Now, you might be wondering to yourself why in the basics section we'd be covering something so complicated as expressions. And really, expressions are not that bad. And they're so ingrained in every single aspect of Houdini that it really is sort of a basics lesson. No matter what you do, you're going to be faced with expressions whether you want to or not in Houdini. For example, in a new scene here, I'm just starting with, the stain build layout that we've been using this whole time. I'm just going to throw down a sphere to demonstrate how ubiquitous the expression system is. So I've got a sphere here, and if I wanted to have this sphere emit fluids using the shelf tool, you can go up here, up top where it says particle fluids, and then we'll say emit particle fluid. And then down here, it's going to ask us to select a fluid object to emit into. I don't have one, so I'm just going to hit enter. And it's going to think for a second and build us a nice flip network, a DOP context so that we can simulate some fluids. So you can see it's made a container here, and inside we've got our particles. I'm just going to hit the D key, turn the background to dark. And you can see that it is, if I hit the play button, we are emitting fluids into our scene. Simple as that. Now, that's cool, but, suppose you actually want to do some stuff with this. You'll see, it's created this DOP network for us. That's cool. And then if I hop back, to our object level, it's created all of these nodes for us, which is all fair. And then if we go back into our sphere that we created, it has also added some nodes here. And suppose you want to change the density of these particles. Well, now you can see we've got our voxel sizes being determined by something indicated by all these kind of teal colors here. Each one of these parameters, if I click on it, you can see that it'll change from the value that it is evaluating to the expression that has led to that numerical value that it is getting. You can see that it is actually looking at a channel inside of our DOP network, looking at the particle separation that was set there, and also looking at the grid scale that was set there. So it's just multiplying those two values together, but it's important to know that this is happening throughout your scenes, because you're going to be doing stuff, and you're going to potentially be able to make some very complicated connections and very intricate and handy connections that keep things super procedural, and it's just essential to know how this stuff works. So let's just I'm going to delete all of this stuff out and start over. And we can, let's go over here. I'm going to hit the D key, and I'm going to also remove the origin gnomon and hit spacebar H to kind of reset our view. So I think one of the examples that was presented to me when I was first starting out learning Houdini was a tutorial, and it was on the Side Effects website, and it was called putting a ball on top of the cube the Houdini way. So let's first put a ball on top of the cube, sort of doing it in the cinema way. So I'm just gonna throw down let's throw down a geo. So we've got our geometry here. I'm gonna dive inside. I'm gonna throw down a cube or a box, and I'm gonna throw down a sphere. So we've got our box and we've got our sphere, and I'm just going to make this sphere a little bit smaller, and we're going to throw down a merge so that we can see both of them in the scene together. Whoops, I don't know how that happened. I'm just going to delete that extra merge. I'm going to select both of these and drag them in and set our display flag to the merge, and you can see that they're both there. Now, if we wanted to set our box on the grid plane, what we might do is we would grab it and we'd kind of, maybe go into our, I'm going to hit spacebar 3 to go into our front view. And, if we wanted to put the box on the floor, we might grab it in Cinema and just sort of place it there. Or we could, we know the size of it is 1. We could set this to 0.5 and it would be sitting on the floor. And then if we wanted to put the sphere on top of the box, we could grab the sphere and, move it up, and see that, it looks like the sphere's got a radius of 1, and it's got a uniform scale of 0.5. Yeah, so we could just kind of, eyeball it, set it on top, and we're good to go. But that's not really the way that things, in Houdini, we like to be 100% procedural. So, for example, if I were to change the size of this box, first off, two things. It's not resting on the floor anymore, and the ball is no longer resting on top of the box. So let's back up a second and do this what I call the Houdini way. So I'm going to, let's go in here to our box. I'm going to just reset its size to 1 and center it at 0. And we're going to also center the sphere at 0 and give it a uniform scale of 1. Oops, not 12, but 1. Let's just focus on our box right now. If I want to put the box on top of the grid, well, we can think about this in a more smart way. Let's say if we look at the size of our box, the size in the Y direction is 1. And so we know that if it's 1 units tall, if we move it up by half of that distance, then it will be resting on the ground. So one thing, and this is probably one of the most important and powerful functions that helped me initially wrap my head around why Houdini is so powerful, is the relative referencing system. And this is really like set driver, set driven, setting driven keys and stuff like that in Cinema. If I were to right click on this size parameter Y, and go down to this function right here, which is copy parameter. And then I drop down to center. I'm just going to select this 0 that I've got, right click, and then I'm going to come down here and say paste relative references, and then hit enter. And so what that has done, if I hop into, I'm going to hit spacebar 3 to hop into my front view, you can see that 0 is down here. It has moved the box up by this amount, which is the size of 1. So if I click on center, you can see that this channel referencing size Y is evaluating to 1. You can toggle back and forth between that. To get a little clue here, if I just hover over size, this size parameter, you can see that it is telling us, this little pop-up that shows up, it's telling us that size X, size Y, and size Z are the parameters. So this directly correlates to the text that is written inside this channel, which it just says channel, opens brackets, and then size Y is referencing this size Y up here, and then it just end quotes and closes it. And just doing that simply allows us to reference this expression for the value of this up here. And it's just as simple as this now. We only want to go halfway up. We just divide it by 2, hit enter, and it is resting on the ground. So now, whenever I change this value, no matter what I do, the box, and switch back to our perspective view, the box is always going to be resting on the ground based off of what we've done here. Cool. Now, because this is only tied to the size Y parameter, if I'm to change the uniform scale, it's still scaling it about the center, like so. So you can see it's actually getting broken a little bit here. And we'll come back and fix that by using the bounding box expression. So instead of using size Y to determine where we want our center to go, I'm just going to delete this out and try something else. So we're going to delete this channel, and I'm going to instead write bbox. Now, at this point, you're probably like thinking, I don't really want to get into learning all these expressions. I think that for procedural modeling and stuff like that, the two most important expressions you can learn are the bbox and the centroid expressions, which I'm going to mostly cover right now. They're super simple, and you can see that now that I've started writing bbox, it gives me this a bbox and an open parentheses. It starts to give me some clues as to how I can use this. And you can see it's expecting a string and a float. A string is simply a path to the channel that we want to reference. In our case, since we're referencing ourself, it's as simple as typing a 0 and then a comma, and then it's expecting a float. And the float value, I think, it's referring to this these values down here. And so if I know that the bounding box of this object is going to be increasing, and therefore it's going to be moving the lower bounds of the object into negative space, I know that I want to move it in the opposite direction of the minimum of this box. So if I type in, if I look down here, I can see, looks like I've got dy, let's see, I've got dy min here. That looks like something that would help me out. So if I type in d_y min, just as it had it in that little helper right here, and hit enter, it's moved it down. We need to actually move in the opposite of the direction of the y minimum. So I'm just going to put a minus sign in front here. Let's see, it's giving me an error here. Oh, okay. This is actually... The reason why this is not working is because it's expecting an input. 0 is referring to the actual input that's leading into this geometry. So I'm actually going to I'm going to back that up a little bit. We're going to take this function and apply it to a transform down here. So instead of manipulating the position of our box on the actual box geometry itself, we're going to do this all in a transform. So I'm going to put in here, I'm going to paste that expression that I did. So it's going to be looking at the 0th input, or this first input of the transform, seeing that the box is incoming, and it's going to transform it in the opposite direction of its y minimum and place it on the floor. So I'm just going to hit enter, and there we go. It is resting on the floor. Now I'm going to go back to this B box because this expression can't evaluate because there's nothing incoming here. I'm going to just delete the channels. So I just right click there, delete the channels, set it back to 0. So now anything I do with this box to change its size in any direction, it is going to be resting on the floor. So now that we've got that out of the way, let's set the sphere on top of the box. So how can we do that? Let's just merge these two together, and then I'm going to grab another transform. I'm going to throw this transform under the sphere. And so what can I do to, like, let's see, bring this sphere on top of the box? Well, I could just grab the, the size and the scale of, I could grab the size and the scale of this box and set some complicated, addition and of these two functions together to change that height of the box. Or I could, let's say, move the sphere first so that it's resting on the ground, and then move it so that it's resting on top of the box. So I'm going to do that. Let's just first focus on what we did over here, which was we took the bounding box of this object and we rested it on the ground. So I just went over here. I'm going to copy this expression out, literally just copying the string using Control-C. I'm going to go over here to translate, and I'm going to paste that in right here. And you can see the sphere is now resting on the ground. So now what I can do is I can add another transform right here. And I'm going to actually reference the position of the box now in terms of its size, not its y minimum. I'll get this little error here. I'm just going to see how I've actually got this. It looks like there's a little bug appearing here, and it's trying to rename my box, but it won't disappear. Oh, and there, it just disappeared. Sometimes if that doesn't disappear, what I'll do is I'll go up top here and create a new network view. And that just simply resets what we were working on, and we can just dive back inside. And this is sort of, it kind of helps clear bugs out like that. I'm sure we'll run into it again at some point. So if you see me doing that, that's what that's all about. Okay, so at any rate, here what we want to do is we want to reference the size of the box, the size of this transform node, and then translate the box up by that size. So in order to make this easy to reference, I'm going to type in null, and I'm going to call this, I'm going to drop this null in my network, and I'm just going to call it box, just to make it easy to reference. So over here, now what I can say is I want to translate my sphere up by the bounding box. Oops, let's lowercase that, b box, open parentheses, and then I'm going to type in a quote. And now it's going to be able to look for a string of an object that's in this scene. So in order to look at another node in the current network that we're in, it's just as simple as writing .. That basically just means go up. Don't look at this node that we're in right now. Look in this, sort of in this geometry, in this network that we're in. And you can see that it is trying to help me out by pulling up possible things that I could want to put in there. It sees the box null that we created here, and it's starting to prompt me for that. If it doesn't show up, you can start typing BOX, and it eventually appears. I'm just going to hit the down arrow and then hit enter, and it writes that path out for us. I'm just going to close this parenthesis, write a comma, and then you can see here now that I would probably want something like my dy size. That would give me the size of that box so that I can move it up in the y direction. I'm just going to say d_y size, and then I'm going to close the parentheses, and the sphere jumps up. And if I merge these two together, you can see the sphere is resting on top of the box. Now, anything I do with this sphere, if I change the size of this sphere, it's always resting on the box. And if I change the size of this box, the sphere is always resting on top of it, and it's always resting on top of the floor. So that's just a nice little kind of demonstration of how you can use expressions to get geometry to behave in a nice procedural way. It's almost like it's almost like constraints or some very like rudimentary rigging that's going on here. So what other cool kind of expressions can we do here? Another one that I really like is to use the frame attribute to drive some animation in our scene. So if I were to, for example, pop up here to our box, you can see like what I could do is I could throw down another transform node right here and then apply some rotation to it and see how that affects the system. So let's throw down a transform. And let's suppose I want to rotate this box along the Z by a certain amount every single frame without having to set any keyframes manually. Well, to do that, what I could do is I could come over here and type in @frame. And you can see it's started to rotate our box. So if I hit play, our box is now rotating. I'm just going to toggle on the real-time toggle. You can see that our box is now rotating, and this parameter right here is evaluating to whatever frame we're on. We're on frame 173. 173 is up here. This @ symbol, you'll see it come up a lot. It's just it's just referring to an attribute, or I believe that this is an attribute that just exists in the entire scene, but that's what that @ symbol refers to. And we'll be using attributes later on in the course, but there are a few of them to know that exist in the entirety of Houdini. There's some very common ones, and one of them is frame. It's a very easy to access and use in functions like this. Now, if you're watching other older tutorials on the internet, you might find some people using the $ syntax to do this, which is similar to like how we set up our global variables earlier, like when we were doing our project setup, like job and $job, etc. So a similar thing that we could do here, if I type in $F, that is also the same as it's also going to evaluate to whatever frame we're on. But because the new the new standard in Houdini is to actually use the @ syntax with frame, we're going to just stick with that in most of our examples here. So if it ever comes up that there's a $ symbol in there, it really means the same thing. Just try to keep that in mind. So we've now effectively set our frame to our rotation angle to be equal to the frame that we're on. Suppose we wanted to rotate a little bit faster. We can just add a multiply by 2. And now it's spinning twice as fast, or we could even go as high as 10. And now it's spinning 10 times as fast automatically without us having to really do anything. Other cool things is in here, because we have this expression, I would argue that honestly, writing expressions in Houdini is almost easier than it is in any other program. A lot of other programs will bury this functionality in some other editor. Now, for example, we could right click on here, go to expression and say edit expression, and that'll bring up a nice expression editor for us. And, you know, we can do all that stuff in here if we wanted to, but I would argue that honestly, this is as exposed and as easy to access as you possibly can. You can be writing expressions all over the place without having to dive into some other separate part of the software, which is what I love about this program so much. So with this cube rotating like so, we can actually, you know, let's see how this has affected our network now. We have it rotating, and we have this node right here keeping it on the ground plane. So now if we rotate, you can see it's actually sort of bouncing along the ground like so, almost doing a little walk. And then if I merge this together, you can see that the sphere is actually behaving like it's wanting to stay on top of the cube roughly as well. So that's like a really, you know, it would be really complicated to have to keyframe this, you know, by hand. And it's already, you know, we've already created sort of a really basic rig for doing some kind of fun little animation like that. So that's just to demonstrate the power of the bounding box. Now, just so that we can go over the one other expression that I find to be super handy, we're going to just, you know, imagine that we want to like stick a pole right through the center of this sphere, and we're going to use the centroid function to do that. So let's just create a tube. And let's just change our tube around here. I want the tube to go along, it looks like the z-axis. I'm just going to make its radius a little bit smaller. We're going to increase its height so that it is sort of like so. Let's just bring this back a little bit to something like, let's do 0.1 and 0.1. Yeah, and then we'll give it a height of 5. And so now I'm going to merge the tube in as well. You can see that everything's doing, you know, in our animation, everything's doing its own thing, but the tube hasn't really been addressed yet. So what can we do here? Let's throw down a transform. We're going to stick this tube right through the middle of this sphere up here. I'm going to bring this guy over, and we're going to want to translate it in its y axis. And so we can go and say, let's say, here we're going to type out our centroid function. So I'm going to start typing centroid and open parentheses. And you can see here that it's looking for a similar thing. We're going to give it two values. One of them is going to be the actual object that we want to obtain the centroid of. And the other one is going to be one of these down here. If you look at the type, it should be one of dx, dy, or dz. So this d underscore y is what we're going to want. So you can see there's some examples here. We're actually going to be doing exactly this. The centroid of sphere 1, which we've created here, dy. Now, it isn't the centroid of sphere 1 as it rests at the origin. That would just leave our tube exactly where it was. We actually want to reference whatever's happening after all of these translations. So I'm going to throw down another null to make it easy to find. And I'm going to say null. I'm going to put this right here and then call this the sphere. Now, if I go over here in my centroid function, it's throwing an error because we never finished it. I'm just going to open quotes. Remember, we're going to do ... and I'm going to start typing sphere, and you can see that it is found our sphere here. I hit the down arrow, hit enter, close parentheses, d underscore y, and close parentheses. Hit enter, and our tube has jumped up to the top here. Now, if I put my display flag back down at merge, you can see that the tube now is locked to the center of the sphere. Now I could actually, you know, because none of these other values are adjusted, you can actually do this centroid on all of these axes. And it's like a really great way to align multiple objects in Houdini. It's just awesome. And, you know, we could even do something crazy like, you know, let's grab our original box, and now we can make it like super long or something like that. And you can see that the box is still staying on the ground. And the sphere is constantly trying to adjust itself to whatever the maximum value is of this box. So even though it's not really resting on the box right now, you could do some sort of type of ray collision to get that to actually stay. But, it is evaluating to whatever this maximum value is here. So, you can make adjustments and it's going to, procedurally modify all of your stuff to kind of all hook together.